recording.
Hello, this is the Margins of Error with our autonomous robotic systems for zoo ecosystem care.
All right, so the problems that we want to address are the zoo sanitation challenges, and that's inconsistent manual cleaning, the risk of disease and pest attraction, heavy labor requirements, limited continuous monitoring, and meeting the USDA sanitation compliance concerns. Our proposed solution is a coordinated 4-robot system. It's automated large waste removal and fine debris vacuum cleaning and surface sanitation and disinfection and continuous inspection and monitoring. And this is a sequential operation for safety and efficiency. And the first robot is a bucketed robot. It collects large waste items, and the exterior components are bioplastics, and the tires are made out of cork, and it utilizes a front sensor to find the waste, and it operates autonomously and returns to its dock and turns off when it's full.
All right, the second robot's fine debris removal. Rubber tracks for uneven surfaces and ease of cleaning. Angled vacuum intake with a protective grate. Removes fur, feathers, dust, light liquids, and spills. Front and rear and side sensors for obstacle avoidance. Automatically docks when tank is full or battery is too low. And a blinking strobe on top to notify operators.
Robot 3 is our sanitation robot. It goes in a snake pattern to sanitize the entire floor. It uses a front sensor to detect when it needs to turn. It senses the walls. It utilizes front wheel drive, and it uses a button when it needs to enter docking mode.
Robot 4 inspection monitoring is called the Overwatch node. It is mounted on the ceiling, stationary, and enacts a continuous left-right center scan of the entire enclosure from the corner. It utilizes 4 sensors that scan the enclosure and provide feedback to the robots and staff. These 4 sensors complete these functions: scan, comparison, temperature, and lighting. There is a red LED light that flashes to signal staff and the robots that parameters are not correct and that a problem exists within the enclosure, and the connectors that allow it to hang from the ceiling are capable of facilitating power delivery and data transmittal.
So inside the enclosure, you have your 4 robots. The fourth one in the corner down here monitors everything like he just said. And then you have your first robot. It'll go, this is not to scale obviously, but it'll go around. It'll pick up all the fine debris and then go back. And then you have your second robot, which comes through and picks up your fine debris. And then you have your third sanitation robot that comes through and sanitizes the floor, moving in an S pattern to make sure that there's full coverage. Benchmarking and value added, so it supports USDA compliance, improves safety, increases efficiency. The current method is manual cleaning, periodic inspection, high labor demands, and consistent results. And with our system, you'd have automated cleaning, continuous monitoring, reduced labor strain, and verified cleaning performances.
In conclusion, this addresses sanitation and safety gaps. It meets design requirement of 95 debris and 90% sanitation and cleanliness. It improves reliability and monitoring. It reduces long-term operational strain. And in conclusion, it's a scalable robotic solution for modern zoo operations.